1, we're going to be talking about solving system of equation using the equal values method. All right? So we're going to answer the question, how can I solve the system? And there's more than one way to solve the system. So today's method is just one method. There are multiple methods. Okay? Question 44 says a set of 2 or more equations with the same variables is called a system of equations. You turn all the way around. Thank you. When you set the 2 expressions that are equal to the same variable equal to each other, like you did in the previous lesson, you are using the equal value method of solving a system of equations. Use the equal value method to solve the following problem. It is time to cool off on a hot summer day. Team Sunshine is filling an inflatable kiddie pool from a garden hose. The pool has 30 gallons in it, and Team Sunshine is adding 8 gallons per minute with a garden hose. Next door, Team Breeze's pool is already filled with 180 gallons of water. They are emptying the pool at 5 gallons per minute with buckets. Write 2 equations that represent the situation. Use the equations to find how long it takes until both pools have the same amount of water. So one team is adding water, the other team is subtracting water. So we're going to use G for gallons, we're going to use T for time, and we're going to write our 2 equations. So our gallons is going to be equal, and the first team is what? Team Sunshine. They're adding 8 per minute, or per minute? Say per minute, yes, per minute. And then the other team is removing water, so theirs is -5 per minute. Okay, so one is +8 and the other one is -5 per minute. Okay, but the first team starts with 30 gallons and the other team starts with 180 gallons. So we've got 2 separate equations. The first one is Team Sunshine. The second one is Team, what are they called? Breeze. Okay? Notice that they're both set equal to G. Because they're both set equal to G, we can take those 2 expressions and set them equal to each other. So we have 8t plus 30, set it equal to the -5t plus 180, and then we're going to solve for the variable t. Since there's t's on both sides, we subtract 5t from both sides. Since we want to get the variable by itself, we're going to subtract 30 from both sides. And then when we divide by 13, we get roughly 12 minutes. At about 12 minutes into this scenario, they're going to have the same amount of water in their kiddie pool. Okay? All right, let's talk about the tortoise and the hare. The tortoise and the hare are having a race. In this tale, the tortoise moves at 50 feet per hour, while the hare moves at 250 feet per hour. The tortoise takes 8 hours longer than the hare to finish. What was the distance of the race? Okay, so if one is going at 50 feet per hour and one is going at 250 feet per hour, we're going to write an equation for each of them. Let t represent the unknown time in hours it took to complete the race, and write an expression representing the time it took the tortoise to finish the race. So this one took t plus 8. Whatever time it took them to finish, plus 8 more hours. That tortoise was really slow, right? Okay, so now part B says write 2 equations that represent the race, one for the hare and one for the tortoise. So this first one is the tortoise, right? He was going at 250 feet. Oh no, hare, sorry. The hare was going at 250 feet. The other one was going at 50, but it took him 8 hours longer. So you have to say t plus 8. Okay? Notice that both of these equations are set equal to D. Okay? If you have D and D, then you can take this expression and set them equal to each other. So you're going to say 250t equals 50 times the t plus 8. What do these little rainbows mean? I need to distribute right there, right? First, I'm going to multiply 50 times t, which is 50t. And then I'm going to multiply 50 times 8. I got 400. Okay. So we're going to subtract that 50t from both sides, which means we have 200t equals 400. And most of you can do this when you're ahead. You don't even need a calculator, right? How many times does 200 go into 400? Twice. So the time took 2, was it hours or minutes? Hours. 2 hours. All right, so D is 250 times T, so they went 500 meters. That's how long it took, or that's how long the race was, 500-meter race. All right, I'm going to move this up. You'll see it in just a second. In case you're still writing. There we go. Okay, question 46. Reynard thought that writing 2 equations for problem 44 was easy. He wants to use 2 equations with 2 variables to solve this problem. Ariel bought several bags of caramel candy and several bags of taffy. The number of bags of taffy was 5 more than the number of bags of caramel. Taffy bags weigh 8 ounces each, and caramel bags weigh 16 ounces each. The total weight of the bags of candy was 400 ounces. How many bags of candy did she buy? Reynard lets T be the number of bags of taffy and C equal the number of caramel bags. Help him write 2 equations that represent the information. So we need 2 equations. The first one has to do with how many ounces they weigh. So the taffy weighs how much? 8 ounces, so we're going to say 8T. How much does the caramel weigh? 16. So we're going to say 16C. Together, they tell us that the bags of candy was how many ounces? 400. So it's going to be equal to the 400. That's your first equation. Has to do with how many ounces it weighs. The other equation is going to have to do with how many bags you have. Right? It says the number of bags of taffy was 5 more than the number of bags of caramel. So if you take the caramel bags, you add 5, that's going to be equal to how many taffy you have. Okay? So those are your 2 equations for that scenario. Part B. Now Reynard, is that how you pronounce that name? Does anybody know anybody with that name? No, it starts with R. Renard? Like Bernard, but with an, okay. Okay. I'm caught up on the name, and that's not even the important part in the quiz. Okay. He says, if both of the equations were in the form t equals something, I could set the 2 expressions equal to each other to find the solution. Help him write the equations into a form he can use to solve the problem. So we're going to take that first equation and we're going to, well, the second equation already is equal to t, but that second equation, we're going to subtract 16c from both sides, and then we're going to divide everything by 8. So if you start with the 8t plus 16c equals 400, you're going to subtract 16c. Then you're going to divide everything by 8. So when you divide this by 8, you divide this by 8, and you divide this by 8, you get t equals 50 minus tc, and t equals 5 plus c. Part C, solve Renard's system of equations to find the number of bags of caramel and the number of bags of taffy that Ariel bought. So we take the two equations or the two expressions and set them equal to each other. So if we have 50 minus 2c equals 5 plus c, we want to get the c's on one side of the equal sign or the other. So we're going to subtract c from both sides. At the same time, we're going to subtract 50 from both sides. Negative 2c minus c is negative 3c. And 5 minus 50 is negative 45. So we divide both sides by negative 3. What's a negative divided by a negative? Positive. So we end up with 15 caramels. And then to get our taffy, we know from this equation right here, we just have to add 5 back to that. So 5 plus the 15, we're going to have 20 bags of taffy candy. Okay? Part D, how can you verify that your solution is correct? We're just going to plug it back in and make sure it's correct. If we have 8 times 20 plus 16 times 15 should be equal to 400. So 8 times 20 is 160. 16 times 15 is 240. So 160 plus 240, we got 400, which is how many bags they told us to start with. Okay? That's how you check it. You just plug your numbers back in and verify that it's going to work. Okay? Question number 47 says, when you write equations to solve work problems, you sometimes end up with two equations, like Renard's or similar to the two equations below. Notice that the second equation is solved for y, but the first equation is not. Rewrite the first equation in y equals form, then solve the system of equations and check your solution. Okay, so we've got two equations right here. We've got x minus 2y equals negative 4, and we've got y equals negative 1/2 x plus 4. The second one's good, right? Put a little star by it. Yeah, we like that. It's already in y equals. So we want to do the same thing with the first equation. So you're going to start by copying it down. X minus 2y equals 4. Then you're going to subtract that x from both sides of the equal sign. That leaves you with negative 2y equals negative x plus 4. How come I didn't combine these two? You can't. They're not like terms. You can't combine them. And so to get that y by itself, the y is being multiplied by negative 2. What's the inverse operation of multiplying by negative 2? Dividing by negative 2. So I'm going to divide all of my terms by negative 2. Divide by negative 2. Divide by negative 2. Divide by negative 2. Okay? Once you divide by 2, you end up with a fraction here. That's fine. Just leave it as a fraction. Because look, the other equation already has a fraction, so no big deal. Okay? And then 4 divided by negative 2 is negative 2. Those are our two equations. We're going to take those two equations, or the two expressions now, and set them equal to each other. So negative 1/2 x plus 4 and positive 1/2 x minus 2, which now there's fractions in there. How do we get rid of fractions? Fraction busting, right? So fraction busting, we're going to look at the denominator, and we've got 2's in the denominator. So I'm going to multiply everything by 2 and then distribute it out here and here, distribute it out here and here. So 2 times negative 1/2 x is just negative x. 2 times 4 is 8. 2 times 1/2 x is x, and 2 times negative 2 is negative 4. So to get that variable by itself, I'm going to subtract x from both sides and then divide everything by negative 2, which makes my answer positive because I had a negative over there as well. So negative 12 divided by negative 2 is positive 6. Once you figured out what your x is, plug it back in. So I'm going to plug it back into the second equation. Half of 6 is 3, but it's negative, so negative 3 plus 4 is positive 1. That means our ordered pair is 6, 1.